Here on Earth, we're under constant attack from space, and I'm not talking about the Russian meteor just yet. More on that later. Charged particles, primarily protons, crash into our atmosphere at close to the speed of light. We call them cosmic rays, and we've finally found out where they come from. I'm Sophie, and welcome to the Countdown. In order to travel so fast, cosmic rays need a ton of energy, more than they could get from any Earth-bound particle accelerator. Researchers suspected these particles were picking up that energy from a supernova. When a star explodes, it releases a shock wave capable of charging up any protons in its path. As those protons stream across the cosmos, they can change course, making it difficult to trace their path. But they also release gamma rays as they go, which provide a clear line back to the point of origin. By studying 4 years of data, researchers have traced distinctive gamma rays back to their supernova sources, proving that cosmic rays originate in supernovae. The paper is in the February 15th edition of the journal Science. Scientists think small meteorites or solar wind may have carried water to our moon after it had fully formed, but the H2O may have been around for a lot longer. When the moon was young, it had a molten interior that solidified into the outer crust we see today. During the Apollo missions, astronauts grabbed rock samples from that crust and brought them back to Earth for analysis. Now, scientists have discovered key signs of water in those samples. In order for water to become part of the crust, it must have existed inside of the early moon. This poses a challenge to the current model of the moon's origin. The theory goes that the collision between a large object and the young Earth blasted material into orbit around our planet. But the impact would have also ejected any hydrogen, leaving the young moon without the ingredients to make water. The moon's damp past may throw a wet blanket over this theory, or at least force scientists to revamp their model. You can read more about the findings in the February 17th advanced online publication of Nature Geoscience. It's always fun to find habitable exoplanets. Of course, if we wanted to travel to one, it would have to be close to home. Well, good news, everyone! According to a new study, there could be plenty of exoplanets nearby. Harvard researchers looked for exoplanets around red dwarfs, the most common type of star in the Milky Way. Red dwarfs are smaller, cooler, and dimmer than our own sun. When the scientists analyzed data from the Kepler Space Telescope, they found 6% of red dwarf systems contain exoplanets, both habitable and roughly the size of Earth. And because 75% of the stars closest to our solar system are red dwarfs, this means some of the exoplanets could be our neighbors, as close as 13 light-years away. In 2011 and 2012, the Hubble telescope discovered 2 additional moons circling Pluto. Pluto's other 3 moons have names from Greek and Roman mythology: Charon, Nyx, and Hydra. But ever since their discovery, scientists have called the new moons P4 and P5, which seems a little unfair. But recently, the fine folks at SETI, who discovered the new moons, announced an opinion poll to give the poor little moons a name. Anyone can go to SETI's website and vote from a list of 21 mythological names. Polling closes on February 25th, and the winning entries will make it to the list of proposed names sent to the International Astronomical Union. Currently, the options in the poll range from the heroic Hercules to the monstrous two-headed dog Orthros. And as of right now, the name Vulcan of Star Trek fame is leading by a large margin. What names would you suggest for Pluto's moons? Let us know in the comments, and don't forget to vote. Unless you live under a rock, no pun intended, you've probably seen this video of a meteor exploding over Russia last week. Experts estimate the meteor, originally an asteroid 15 meters across, released energy equivalent to 300 kilotons of TNT. The explosion rattled buildings and blew out windows in the city below. So why didn't we see it coming? Well, we do have a network of telescopes searching for near-Earth objects, but they're looking for asteroids that are much bigger, between 100 meters and 1 kilometer across. There's also a good chance the Russian asteroid was a dark color, making it hard to spot against the backdrop of space. For small asteroids we can't see, there may be no way to predict or prevent a strike. But for big ones, like 2012 DA14, the giant space rock that buzzed Earth last week, we have a couple new tools in the arsenal. First, the Atlas system. 8 small telescopes with 100 megapixel resolution will begin scanning the skies twice a night, starting in 2015. The system will give a week's warning for a 45-meter asteroid and 3 weeks for much larger objects. NASA's OSIRIS-REx spacecraft will give us the most accurate reading yet of the Yarkovsky effect. This occurs when the heat an asteroid absorbs from the sun radiates back out, changing its trajectory. If we can measure this effect, we'll have a better sense of if and when an asteroid might hit Earth. And 2 scientists from California just announced an idea for obliterating any near-Earth objects headed our way. Their system, called D-STAR, would harness the sun's power to direct a laser beam at incoming asteroids. A small beam could push a space rock off course, and a large one could whittle it down to nothing. But until we can apply these technologies to smaller asteroids, we'll likely be surprised by another attack from space. And that's your countdown. For links to all of these stories and more, visit scientificamerican.com/thecountdown. The link's in the description below. You can also subscribe to the Space Lab channel or watch another video. For Scientific American, I'm Sophie Bushwick, and I'll be keeping an eye on the sky.